So good afternoon, everyone. My name is Francesco Petruccione. I'm the director of NITheCS, and it's a pleasure to welcome you to this micro school. Yeah, as you know, the micro school is a new NITheCS offering. And in these, let's say, 20 minutes kind of lectures, we want just to introduce a particular skill that can be of great benefit for your studies, for your research, for whatever you need to do in this world where everything is numerical and theoretical. Yeah. So, and today we are very lucky to have Pashlene Naidoo with us. Pashlene did her undergraduate studies and her honors at UKZN and recently moved to Stellenbosch University, where she's doing her master's with Dr Yaseera Ismail in an experimental topic around quantum communication. Yeah. Pashlene, thank you very much for offering this micro school. And before I ask you to start, I would like to appeal to the participants. If you have any skill that you are happy to share, yeah, in this 15-minute, 20-minute format, yeah, even in a series of micro lectures, yeah, please drop us an email, and we will be very happy to introduce you to make you part of the program. Yeah, we've chosen this Friday 12 o'clock slot going forward because we hope that most people can sneak out of whatever they're doing during the day on a Friday lunchtime and learn something useful in 20 minutes. Yeah. So please, if you have suggestions or you want to offer something, we want to have this as a kind of a peer-to-peer kind of instruction. Yeah. If you're a master's, PhD, honor students, or postdoc and want to share some skill, please let us know. Okay, Pashlene, thank you very much. You already started sharing your Jupyter notebook or your Colab notebook. Yeah? Please, over to you, and let's try to stick to 15, 20 minutes. Thank you very much.
Okay, thank you. So today I'm going to be presenting a tutorial on Pandas. Pandas is an open source library used for data analysis and machine learning. You can have a view on the Pandas documentation using this link, and I will upload my Python notebook on my GitHub later on. So the first thing to do is to install Pandas. Once Pandas is installed, we need to import Pandas as PD. We refer to Pandas as PD every time we use its functions. So we are using the Pandas version 2.0.3. Okay. And now we are going to understand what a series is. So a series is a one-dimensional array, also known as a column. And we start to create a series by creating a list. In this instance, we create a list of cars, and we feed the Panda series function the cars list, which creates a series called mycars. We run this mycars series, and we can see a column of all the car names. We then can create another series, another list describing the number of cars of each kind. We feed this list into the series function, and we run this code. We can see we have created a column of integers. So to create a data frame, we can combine two series. We're going to combine our two series that we created. We can, well, a data frame is a two-dimensional array. We can think of a table that has columns and rows. We use the data frame Pandas function where we feed in the two series that we created and along with their column names. So we kind of create a sort of a dictionary, and each column is separated by a comma. This data frame function creates a data frame called garage_home. We run this data frame, and we can see a nice visualization of our database. Another way to create a data frame is to use a list of tuples. In this case, we have this is a tuple that has two inputs. We insert this tuple list into the data frame function along with the column names for each input in the tuple. We run this code and we see a similar database or a data frame in the output. We can extend our data frame by creating an additional column. We can do this in two ways. We can create another series, or we can add another input in our tuple. In this case, here we have 3 inputs in our tuple. We then insert our list of tuples in our data frame and define our columns. And we have an extra column called color of car. And when we run this data frame mygarage_Monaco, we have a data frame that has 3 columns. Okay, so it's also useful to access specific pieces of data from our data frames. So let's say you want to access a specific row in the data frame. You can use the function loc. This will locate the row index that you want. So you input the row index. And when you run this code, you get the columns and the data in that specific row. If you want to access a specific column, such as the car brand, you call out your data frame and you use the square brackets to sort of grab the desired column by inputting the column name. When you run this code, we get a column of all the car names. If we want to get a specific element in a column, let's say we want to get this Ferrari element, we think of it in terms of rows, columns and rows. So it's in the car brand column in row 0. So that's what we write in our code. So we access the mygarage_Monaco data frame where we access the car brand column that access the row 0. And we run this code and we get the element Ferrari. We can even replace elements in columns. Let's try to replace the Ferrari element. We can use the locate function again, where the first input is the row index and the second input is the column index or column name. And we can assign that value to Tesla. When we run this, the mygarage_Monaco data frame, we can see that Ferrari has been replaced with a Tesla. So let's say you also want to change another element in the data frame. You can update the columns using the same locate function, and you can change the values however. So if we multiply the initial value by 5, and we can see that the number of cars has changed to 5 for Tesla. Okay, it's also useful to understand the data types in each column. So we use the dtypes function, and when we run this, you see all of our column names as well as the data type in each of these columns. So here it says that the data type for under the column car brand is an object, and an object is just a string that we used. To make our data frame look more nice, we can remove this these indices by using the set_index function. This is so to get rid of the index, you have to replace it with a column that's unique. So in this case, the car brand column has unique values. So we insert the car brand column and we see that the indices have been replaced with the car brand. We can also save our data using the to_CSV function. So this data this data frame that we created, this is called the new underscore df. We want to save this data frame, we use this function, and inside this function, we create the file name that we want to save the data in. So if you run this, you will see if you use Google Colab, you will go to the file icon and you can see the cardData.csv file. If you double click on that, you can see the same data being saved here. Okay. In Pandas, we can also plot to get a more detailed understanding of our data. So we can use the columns in our data frame as our X and Y axis data. In this case, we use the car brand, the car brand column in the My Garage underscore Cape Town data frame and the number of cars column as well. So I have created different types of plots using the same data. And if we run this, you can see that you see a pie chart, a bar graph, a line graph, and a scatter plot. Comparing or understanding the relationship between the car brand and number of cars. So that's a nice introduction how to use Pandas, and extending that, we can also create a data frame by reading in a CSV file or Excel file using the read.csv function. So let's say you downloaded a data set from Google or Kaggle. You download the file and you go to your file icon, you drag and drop your file here, you go to the three dots, you copy your paths, and you paste it here in between quotation marks. If your file is encoded with the Latin 1 encoding, you have to define that so that Pandas can read it correctly. If you don't know what the coding is, you can use Google or ChatGPT or Gemini to help you solve what kind of coding it is. Then, so our data set has about 5,000 rows. So we don't want to see all of it. We just want to see a few rows. And this head function by default outputs the first 5 rows of the data set. So our data set that we're going to be working with is the most streamed Spotify songs in 2024. We can see the album name, the artist, the all-time rank, and the Spotify streams, and many other columns. We can also use the tail function that works similar to the head function. If you just want to see the first 2 or the last 2 rows in data set, in this case, we can put a 2 in between the brackets. If you want to see 10, you put 10 in between the brackets. And this function is also set by default just to show the last 5 rows of the data set. So as we have shown in the beginning, we know how to get a specific column, and we know how to get a specific row using the locate or the loc function. And now we just want to understand our data a little bit more. So let's look at our data again. We can see that it has a lot of commas, and Python normally doesn't use commas. If you want to define a float, we use a decimal. If we have empty values, we should change it to a 0. So this is identifying different types of data that we need to change. And this is the first part of how we can clean out our data. So to understand our data better, we can view the data type of each column, and we can see that the track column and album column are objects, which is true. And we can see that the all-time rank is an object, but it should be an integer. And the YouTube views and YouTube like should be integers as well, but they are objects. So we have a nice understanding on what we need to change in future, and we're going to do that soon. So let's begin cleaning our data. So to make our data frame look more nice, let's try and set our index to a column with unique values. So I'm going to set this index to the ISRC column or code. I'm not sure what ISRC stands for, but I think it's like serial number for each type of song. We run that, and then we can see our data frame created. You can see that the indices have been replaced by this ISRC number. So we can then try and create a new data frame, because in the initial data frame, we can see there's a lot of columns being used, and we're not going to use all of them. We're just going to use a few columns. And in this case, how to subset your data is that we're going to create a data frame called My Songs. Then we use the data frame, and we input a list of columns that we want to use. And when we run this, we can see a data frame displaying all the columns that we want. Okay, and we can continue to see the different data types in our My Songs data frame. We see that they are objects, and now we're gonna convert them all into integers, and we're gonna convert the release date column into a date time data type. So let's look at the all-time rank column. We access the column, or the all-time rank column, and then we identify it for what it is. So the all-time rank column is a string. We identify it as a string by using the as_type function and inputting str for string. Then only we can replace the commas with no commas. As you can see here, if we go back to this data frame, we can see that the all-time rank column has a few of these commas, and we should remove these commas so that we can convert them to an integer, because integers don't have commas and decimals. Once we replace the commas, we can then convert it into an integer using the as_type function and inputting it with int for integer. Then we run this code. You see a tick there, so it means that the code ran correctly. We do this for the Spotify streams. But in Spotify streams, we can see if you look at the data, you might see that there are some spaces that are not filled. So you want to fill those spaces with a string 0. And then once we do that, we define the data as what it is, string, then we replace the columns, and we replace the commas with no commas, and then convert it to an integer. Do the same for YouTube views, YouTube likes, all these columns that we are working with. And for the release date column, we use the date time, the to_datetime function to convert the object data type to a datetime data type. So all of those have run. We can now see the data types again, and we see that all the columns have in the correct data types. Okay, so now we can view our clean data using the head function, and we can see that our data looks much more cleaner. Our empty data has been replaced with zeros. Our release date has been has been corrected into its correct version, and it's just easier to work with now. So now we can use our clean data. Let's say we want to find the top 10 songs in 2024 currently. So we create a data frame called my top 10 songs. We access the my_songs data frame, which is this data frame here. And then we use the loc function to locate the data in the all-time rank column that is less than 11. When we run this, we can see that the top 10 songs of the data set, or all the numbers that are less than 11. We can also create a new column for our my songs data frame. Let's say we want to create a total views column in our my songs data frame. We can combine two existing columns. We combine the YouTube views and TikTok views. And then when we run our code again, we can see, when we run our data frame again, we can see the total views column added. So we can then use the describe function to describe some of the statistics in our data frame for each column. If we run this, we can see that some statistics for each column, such as the minimum value, the maximum value, the 50th percentile, and so forth. We can also plot our columns as well. We can, if we want to see the relationship between Spotify streams and YouTube views, we can just put in the X and Y data that you're going to use in the scatter function, and you can label X and Y labels and include a title. You run this code, and we can see a relationship between Spotify streams and YouTube views. We can also save our clean data. So this data frame my_songs data frame has our clean data. We can save the file using this to_csv function. And we named our file that we want to save it in. If we run this file or this code, we look into the files icon and we can see our processed data. If we double click on that, we can see our clean data, as we see here, the same type of clean data. So I think that's a nice introduction on Pandas, and we've learned some basic data cleaning and how to create data frames. Thank you for attending.
Yeah, thank you very much, Pashlene, for the very nice introduction to the use of Pandas, and hopefully going forward, you will give us some mini micro schools on more advanced features of Pandas, yeah, because this is just the appetizer to start using it. So thank you very much. Are there any questions from the participants? I think there was a raised hand. And Mukadi, I can give you the right to speak. You can ask your question directly to Pashlene. You just have to unmute yourself. Okay, Mukadi. Here we go.
You wanted me to ask the question?
Please, yeah, ask the question. Yeah.
Okay. I don't have any questions to ask right now.
Okay, because your hand was raised. I thought you wanted to ask a question. Okay, then it's fine. Thank you. Thank you very much. Are there other questions for Pashlene? because there is nothing in the Q&A. If there are no urgent questions, then please just take a second to fill out the little poll that I just opened on your screen, because that is very useful feedback for us to know how we can improve, what we can offer, and it just a few clicks. Yeah, so thank you very much for that. And please remember to, if you have skills that you want to share with colleagues and peers, just drop us an email and we will include you in our micro-school program with great pleasure. Yep. So thank you very much again, everyone. Have a good rest of the day and a good weekend. And please, if you are in the Western Cape, try to stay inside because it's cold and very wet outside. Yeah. So, and Pashlene, thank you very much for putting together this very interesting, sorry, this is my phone ringing. Thank you very much for putting together this very nice micro-school. Sorry, I should have muted my phone earlier. Yep. So thank you very much, everyone. Thank you for filling out the poll. We will analyze it and I will share quickly the result with you. And I see there are lots of compliments coming to Pashlene. So thank you very much. Yeah, excellent. Then again, a good weekend to everybody, and we will see you soon for another micro-school that we will announce very soon. Thank you very much. Thank you. All the best. Thank you very much, Pashlene.
Thank you.